Hi, I was asked by a student to help him with question 11. It's out of exercise 5B. See, exercise 5B on page 221. It's question 11. And yes, it is a challenging question. So let's have a look at what we need to consider. Well, first of all, let's understand the problem. The problem is we need to find the dimensions of the frame painting. That's point number one. And for 1 mark, please make sure you do follow the instruction. That's the nearest millimeter. So let's have a look at this problem. We have a painting. And we are asked to find the dimensions of it. Obviously, what they want you to find is its length. Call that X, because we don't know what it is. That's what the question is. And of course, we want its width. Now, here we might want to introduce our two most common variables, X and Y. And by now you should know that when we have two unknowns, we need two equations. And because we have two equations, we need to know how to do it doing what's called simultaneous equations. And in the previous topic on linear equations, we learned how to do simultaneous equation solving. So there we go. Now, can you see the two equations in there? And the key is the equal sign would be the word is. And there we are. So one relates to the perimeter, which is length. The other one relates to the area, which is, of course, the area of a rectangular shape. So let's look at that. So we now know that the perimeter is 100. That's y plus x plus the other y plus the other x add up to 100. That's 2y plus 2x equals 100. Or for some students to simplify it already, we have y plus x equals 50. That's equation 1. So x plus y equals 50 centimeters. The next part, of course, is the equation. It says that there's a 2 centimeter edge around that frame or picture. And so in actual fact, we have the situation where the picture itself, which is this area, we know is 300 centimeters squared, which is the length and width. But of course, this length here has been reduced by 4 centimeters. And this width has also been reduced by 4 centimeters. So our second equation, so that is equation 1, our second equation will be the area. So that's x minus 4 centimeters multiplied by y minus 4. We're told the area is equal to 300 centimeters squared. So now we are ready to do the solution process. And that's, of course, simultaneous. Remember, we have two unknowns. We need to solve them at the same time. So we're going to use either the substitution or elimination. And clearly, what we're going to do is use the substitution. We might replace that y from that equation into that y. So we're going to substitute. We're going to use the substitution method. But before we can do that, we need to set up so that's y equals. So transpose equation 1. So that's x plus y equals 50. Subtract x from both sides. We have y equals 50 minus x. And now we're ready to substitute that into equation 2. So sub. This time we substitute, make call that equation 3, substitute equation 3 into equation 2. So we have x minus 4, we're replacing the y with 50 minus x minus 4 equals 300. And let's simplify that second expression. So x minus 4, and that's going to be 46 minus x equals 300. And by now you can recognize that what we have is a quadratic. And so to solve for x, we're going to use one of two techniques. And the reason why we're going to do one of two techniques is because this is most probably an analysis type question found in the tech table. So we have our calculator at our beckoning. And hopefully you know how to use your calculator. Let's go there to our calculator. Here we go. Remember, on the calculator page, we'll get the exact form. So again, you need to look at how they want you to go and express your answers. And on the graph page, you'll get the approximate, or in other words, decimal form. And I think you can see that they want us to use the decimal form. So, but I'm going to use both techniques just as a way of demonstrating. One option, of course, we might want to expand that so we can see that in actual fact it is a quadratic function. So I'll pause that while that loads. Okay, so let's go to the calculator page for exact. So remember, we want to expand the brackets so we can express that in a much more appropriate way. That's option 3, expand. Remember, they're not your brackets, so we need to bring in the new brackets. That's x minus 4. Jump out, cursor across, open up another set of brackets, and that was 46 minus x. And press enter, and there we have it. So we can now continue on with the problem. And as I say, don't try and reinvent the wheel. If you've got access to your calculator, do so. So let's go to another page, and we got from the equation, we had minus x squared plus 50x minus 184 equals 300. We'll transpose, we'll get rid of that 300, so subtract 300 from both sides. We have that to solve for x, we'll use the null factor law. There we are. There's our null factor law, which we can use our calculator. So going to our calculator again, menu algebra for 3. Remember, oops, control escape. Let's try that again. Menu 3 for algebra. We could either solve or we can go use the zeros. So again, this will find out what values of x for when it is equal to 0. So be careful. It isn't that one because remember we took the 300 across, so make sure you got 484. Don't forget you need to tell it for what variable. Don't know why. It's the only variable I've got there, but anyway. And there we have in basically in exact form. We could maybe convert it into so press enter and control enter and should give us in decimal. So there are the solutions of the x values. We have 2 to choose there, and that's 13.1257 centimeters and 36.87. So clearly they want us to, that's in centimeters. So we need to go 31.2, nearest millimeter, that's 131. The other one is 36.8 or 368.7. So the nearest millimeter is 369. The other option, of course, would to be graph it. So let's go to graphing. So remember the function was negative x squared plus 50x Remember, we brought the 300 across and it made it equal to minus 484. Press enter. Don't see anything. And that's what you most probably think, oh, it doesn't work. Remember, it's menu, Windows, Zoom, that's option number 4. And we want to fit the function in there. And it is really wonderfully weird. So you might want to zoom out some more. It didn't do a very good job of that. So zoom out. There we are. Zoom out again. And there's our 2x intercepts. So menu, trace, graph trace, and cursor across. Oops, X. Press something extra. Okay, so menu, 5 for trace, 1, and cursor across. And there's our 113.1 centimeters or 131 millimeters. And the second one, so we could have just gone and traced earlier and just waited for it to finally find, and the other one is at 36.9 centimeters or 369 millimeters. So all we need to do now is record that. So going back to our thing, so we have x equals either 130, 131 or 36.9 centimeters. And don't forget they want it in millimeters. And so that's the dimension of our painting. I hope that helped you, and let's go back. So when it comes to problem solving, two unknowns, two equations. When you have two unknowns, you have to solve them simultaneously. And here we had a mixture of a linear equation and a quadratic. So, yeah, hopefully that helped you. Have a good day.